Hi guys, and welcome back. For our second video for today, we will not be graphing. What we're going to do in this video is we're going to try to figure out if a problem has a solution without graphing it. Now, since we're not graphing, we won't be able to find the actual solution. We're just going to try to figure out, is it a normal linear equation where it has an ordered pair solution? Or is it one of those two special cases that we talked about at the end of our last video? Beyond that, we're not going to be learning what the actual solution is. To be able to tell whether or not a problem has an answer or if it's a special case, you always want to put your equations into slope-intercept form, just like we did in the last video. So slope-intercept form is fantastic because just by putting it into slope-intercept form, you can tell whether or not it has a solution. Slope-intercept form, when we're graphing, is fantastic because it gives us an accurate graph. But for our second set of notes today, and for the second part of your homework, you are going to try to do problems without graphing. And so right now, go ahead and pause the video and copy this table into your notes, and then we'll fill out the table together. All right, so when you put your equations both into slope-intercept form, if you have two equations that have the same slope, that means if you were going to graph it, you would get parallel lines. When you graph parallel lines, they do not intersect, and so there are no solutions. If you want to see an example of parallel lines, I'm going to do the best I can with my mouse. We've got 1 and 2, okay? So again, if you put your equations into slope-intercept form and you notice that they have the exact same slopes, then you could tell me that this problem has no solutions or zero answers. If you put both equations into slope-intercept form and you notice that they have different slopes, doesn't matter what they are. They could be opposite and reciprocals, or they could just literally be two different numbers, 2 and -5, right? It doesn't matter. They could even be like 1 and -1. If the slopes are the teeniest of tiniest of bit different slopes, those lines are going to intersect. They're going to cross. It doesn't matter how they cross. It doesn't matter if they're perpendicular or not. They're going to touch. And that's what we're looking for, right? We're looking for a point of intersection. Okay? So intersecting lines are just two lines that cross. They might cross at a 90-degree angle, or maybe they cross like this. Like, I don't know, but they have to cross. That will happen anytime you have different slopes. So anytime that you have two equations with different slopes, there's definitely a solution to that answer. It's only one solution, and that solution is an ordered pair. So the solution will have two numbers in it, but it's considered to be one dot. So we say that that has one solution. The final scenario is if you change your equations both into slope-intercept form, and they are literally the exact same equation, same slope and same y-intercept. When you go to graph that, you're going to graph the same line twice. So you're going to end up with only one line graphed on the coordinate plane, because the second line is going to be on top of the first line, so you won't be able to even tell that it's there. If you notice that the equations are exactly the same slope, same y-intercept, then you could tell me that that problem has an infinite amount of solutions. For the second half of your homework, it just wants to know how many solutions are there. It doesn't want to know the actual answer. So you're going to change everything into slope-intercept form. And then the potential answers on the second half of the homework are there are no solutions, there is one solution, or there is an infinite amount of solutions. This concludes today's lesson.